In this tutorial, we're going to talk about a powerful programming technique called recursion. To begin with, I'd like to talk about the factorial function. Now, if you're not familiar with this, it's a mathematical function defined by the exclamation point. And when taking the factorial of a number, you multiply that number by all of the other numbers that are less than it. So for example, we could take 6 factorial, and that's the same thing as 6 times 5 times 4 times 3 times 2 times 1. So if I asked you quickly to give me the factorial of 75, you might say that it's 75 times 74 times 73 and so on. But is it not true that 75 factorial is the same thing as 75 times 74 factorial? In fact, when we look at it this way, you can see that factorial is defined in terms of itself. So to solve the 75 factorial problem, we actually need to figure out what 74 factorial is. And then when trying to figure out what 74 factorial is, we have to figure out what 73 factorial is. And the same thing is true with 73 factorial. We have to figure out what 72 factorial is. So the question is, when would it stop? Well, at some point we would figure out that 1 factorial is simply 1. If we look at this generically, you could say that n factorial is the same thing as n times n minus 1 factorial. So this leads us into recursion. Recursion is when a method calls itself, and therefore it's easy to identify. What's going to happen is we're going to create a series of clones of the function, and then usually we pass that clone a smaller problem of work. There are 3 requirements for recursion. First, you have to have the recursive call, you have to have some kind of terminating condition, and then you have to make some kind of progress towards terminating. So here's an example of what it would look like if we coded up factorial in C#. To begin with, you can see that the return type is an int. The method name is factorial, and it takes in an int that we'll call n for now. Now if n is equal to 1, we're going to return 1. In other words, if we were to call factorial with the value of 1, 1 would come in here to n, and then we would simply return the value 1. If it's not 1, then what we're going to do is to return n, the value that was passed to this function, times the recursive call here of factorial of n minus 1. So for educational reasons, I put in a couple of console.write lines here, and that's going to allow us to trace through and better understand these recursive calls. And to help us to be able to trace through, we're going to work with something called a function stack. The idea here is that we're going to call a function and then we're going to push that onto the stack. So to begin with, we'll start here in main, and you can see this is where we initially call factorial, passing it a 4. So we'll jump up here to the function, and you'll notice that n is equal to 4. Also notice that we've pushed factorial of 4 on the stack, and I've just abbreviated calling it fact of 4 instead. Now as this function runs, the first thing that it's going to do is to console.write line the value n. In this case, n was 4, so the output is going to be 4. Continuing down, you'd see that we do a check to see if n is equal to 1, and it's not. So we jump down here to the else, and you can see that we're going to calculate a result. And in this case, the result's going to be 4, because n is 4, times the factorial of n minus 1, or the factorial of 3. Now notice that we've got a lot of pending work here that I can't do yet. And the reason is because I've called this factorial function, and it has to finish before I can go down to this console.write line. So let's go ahead and figure out what the factorial of 3 is. So again, notice what's going on here. N is currently now 3, and I've got the factorial of 3 that I've pushed onto the stack. So the first thing that's going to happen inside of this clone is that it's going to console.write line n, and again n is 3 for this clone. We again do our check to see if n is equal to 1, which it's not. And then we jump down here to the else and calculate another result. Now notice because n is 3, the result is going to be 3 times the factorial of 2. Notice that this clone has a lot of pending work as well that it can't get to because again we've called the factorial function. So what we do is we push factorial of 2 onto the stack and have another clone. In this case, n is equal to 2. So the first thing that we do for this clone is to console.write line n, which is 2. And you can see a 2 in the output now. We do the check to see if n is equal to 1 again, which it's not. So again, we jump down here to the else and we calculate another result. In this case, the result is going to be 2 times the factorial of 1. And just like the others, this clone has pending work as well. So where it gets a little bit more interesting is when n is equal to 1, which is the case for this clone. So for this clone, you can see when it does its console.write line, it's going to output 1. And then we do our check. Now in this case, n actually is equal to 1, so we figured out that the factorial of 1 is actually equal to 1. So therefore we've terminated, and by terminated, notice that we haven't done yet another recursive call. So at this point, because we've terminated, you're going to see that the stack is going to begin to collapse. It's going to return back to main. Also notice that we figured out that the factorial of 1 is actually equal to 1, so we're going to do the substitution down here. Remember, factorial of 2 was waiting for the results from factorial of 1. So what's going to happen is we're going to pop factorial of 1 off of the stack, and then we're going to replace that factorial of 1 call with the actual result of 1. Now what's happening is factorial of 2 is currently on the top of the stack, so it's running, and remember, it had a lot of pending work. So now what can happen is when we do a console.writeLine of n, for this clone n was equal to 2, so therefore we're going to output 2 to the screen. The 2 clone is still running, so it's going to return its result. And again, you can look over here, and it's a simple multiplication, 2 times 1. Therefore, factorial of 2 is equal to 2. Now, if you remember, factorial of 3 was the one that called factorial of 2, so it was waiting for the results of that. So just like we saw before, we're going to remove factorial of 2 from the top of the stack, and we're going to replace the call to factorial of 2 with the value of 2. Factorial of 3 also had a lot of pending work, so we can finish that out now. So when I console.writeLine n, because n is equal to 3, we're going to output a 3. Similar thing is going to happen here. Now we know that the factorial of 3 is equal to 6, so we're going to do this substitution again. So I remove factorial of 3 from the top of the stack, and I replace this call to factorial of 3 with the 6 that it figured out. Now just like the others, factorial of 4 is now at the top of the stack, and it had some pending work. So when we console.writeLine n, because n is 4 for this clone, it's going to output 4. And then we're going to return the result back to who called us. Now realize that the factorial of 4 clone was actually called from main. So because factorial of 4 is equal to 24, we can now pop this off of the stack, and then I can replace that call with the value 24. At which point we can console.writeLine f, and you can see that a 24 appears on the screen. So that's it for this tutorial. Hopefully you understand a little bit more about what recursion is and how to use a stack to trace through these recursive function calls.